Today we're talking scatter plots and lines of fit. A scatter plot is a graph that shows the relationship between two data sets. The two data sets are graphed as ordered pairs on a coordinate plane, and it's easy looking at a scatter plot to identify trends that we see in our data. A correlation is a relationship between data sets. A scatter plot is a great way to identify and describe a correlation that we see between our data. A line of fit is a line that is drawn on our scatter plot that's close to most of the data points. The data points aren't going to form an exact line, but this line will go through some of the data points and it'll have some above and below, but it's close to most of the data points. When data shows a positive or a negative correlation, we can draw a line of fit on our scatter plot. Let's look at our first example here, interpreting a scatter plot. So this scatter plot shows the amount of X grams of sugar and Y, the calories, that are in 10 different smoothies. So here we have our sugar on the x-axis, our calories are on the y-axis, and we've plotted 10 different smoothies. So here we have a smoothie that has 62 grams of sugar, and I can see it is 290 calories, and we have 10 of those data points. So they want to know how many calories are in the smoothie that contains 56 grams of sugar. Well, since sugar is on our x-axis, I'm going to find where 56 would be, between 54 and 58, and follow it up. And that smoothie, if I follow it over, had 270 calories. So there are 270 calories in the smoothie with 56 grams of sugar. Here they're asking how many grams of sugar are in the smoothie with 320 calories. Well, since calories are on the y-axis, I would find where 320 is all the way at the top, follow it over. I only have one data point, one smoothie with 320 calories, and it has 70 grams of sugar in it. So here they're asking us what tends to happen to the number of calories as the number of grams of sugar increases. Well, as the sugar is increasing, it appears that so are the calories. So as the sugar increases, in general, so do the calories. So let's talk about different correlations. So when we plot things on a scatter plot and we see that as the X values are increasing, so are the Y values, and it appears like all the dots are going up as we travel from left to right. This is called a positive correlation. If as our X values increase, our Y values are falling, our Y values are decreasing, we call this a negative correlation. And if the dots are all over the place and I don't really notice a trend, it doesn't seem like they're all going up, or as one goes up, one is going down, they're just jumbled all over. This is no correlation. There doesn't seem to be any specific trend here. So they're asking us to look at these graphs down here and identify any correlations. So here they interviewed people about what is your age and how many vehicles you've owned. And I kind of noticed the data is just all over the place. There isn't a definite trend here. So I would say we do not have a correlation here. So this graph is about the temperature and coat sales. And it seems that as the temperature rises, our coat sales are lower. So when the temperature is cold, the coat sales are high. And as the temperature goes up, the coat sales go down. So we definitely have a trend here. This is a negative correlation. So what if you're going to use a scatter plot and a line of fit to model data? The first thing that you want to do is make your scatter plot of the data. So create a graph, put all your data points on the graph. Then you want to decide whether the data can be modeled by a line. Do I see a positive or a negative correlation? If I do, I want to draw a line that appears to fit the data closely. There's going to be some points above and some points below, but you want to have about an even amount above and below. Then you're going to write an equation using 2 points on the line. The points don't have to represent actual data points, but they have to be points that your line goes through. All right, so here I have some data. It's 8 weeks of data, and it's telling us how many sales there were in millions of dollars. So DVD sales. So in week 1, there were $19 million in DVD sales. In week 2, $15 million, and so on. So I've graphed all of these data points on my graph here. And I noticed that there was a negative correlation. So I drew in what I thought was a line of fit. I tried to have, my line went through some points, but I tried to have some above, some below, and make it fairly even. So I have here 3 points above, 3 points below, and it looks like it goes through these 2 points. So I want to write an equation for this particular line that I put on the graph here. So since it goes through this point right here, and this point is 5, 10, I'm going to use that as one of my data points. And it also looks like it goes through this one right here, which is 6, 8. So I'm going to use these two to find the slope of my line. So I'm going to subtract my y's, 10 minus 8, and I have a rise of 2. And I'll subtract my x's, 5 minus 6. I have a run of -1. So overall a slope of -2. So y equals -2x plus, and it's crossing the y-axis at about 20. So now I have a line, an equation for my line that I can use for this data. So I notice that in general, my sales are going down roughly about $2 million per week. So I have my -2. So it's going down across the weeks.